Hi folks, I hope you're having as much fun with your Casio FX9860G2 as I am. I thought I'd show you a little bit about how to program. So what we're going to do is we go from the main menu to this here, the program, and we select this. Now there's no programs yet on this. This is my emulator. This is actually a computer emulating the software here and the calculator itself, but it lets me do everything the calculator would do to show you. So let's make a new program. First of all, we have to give it a name. Let's do something that we're doing currently. So we're doing gravitational. Let's maybe do a program about potential energy or gravitational potential even. So first of all, we need to give it a name. So let's call it potential. In fact, you won't fit all of that in because it doesn't let you have, there is a limit on the number. So if we just call it pot 1, remember to take the alpha lock off for pot 1. And then we press the exe button, and this has given program a name and given us the sheet to write the program. So next thing, if we're doing gravitational potential, we want the gravitational universal gravitational constant, big G, and we know that this is 6.67 times 10 to the minus 11, and we need to store this, so we're going to store this in a memory location. And what we'll do is we use this arrow here, the assignment arrow, and we will assign that. Again, your alpha lock, remember any of these letters can be a memory location where you store a value, and we'll store it in G. Then exe gives that all a line by itself. So that's an executable line, and that will assign this value into G. Now we're going to enter some data. We're going to ask the user or yourself when you turn your calculator on to enter some data. So we want a little string first, so we do this with quotes. Here's quotes on the EXP button. Again, you've got your alpha lock on, and we can say, let's say enter. I'm not so used to where these letters are yet. Enter. There's a nice space button here. We get space, and then we could say enter mass. So M-A-S-S. Now what we'll do is we'll close the quotation marks, enter mass, and we want to take that and put it in a value, or take the value that's entered and put it in a memory location. And to do that, it took me a while to find this one, but you have to press shift and then this program. You're highlighting shift program on the vars button, and then the little question mark here. This means that the computer is going to take in some input, input, and what we're going to do is assign that now to, let's put that in memory location, so alpha, remember to get my M, and we'll put that in M. Where's the M? There we go. So that's going to take the mass and put it in M. And then I think what we'll do is we'll enter the distance or the radius which we want to calculate the potential. So again, we want the radius as input. So if we click here and again do our alpha lock and then say to ourselves enter. Oops, you see, you even make a mistake, go back, not a problem. Enter. You can tell this is my first one, eh? Enter. So where's the T? And where's my argon? Enter. Again, space. We want space. And we'll say radius or R. Let's just put R. Save me finding it all again. So R. Close your quotes. Now remember, we want R. We're taking in a value, so shift program on the vars button and select the question mark, then the assignment arrow, and then we'll put this into R. Let's put this into R, location R, and we'll give that a line all by itself. So now we've got a gravitational constant. We're going to take in a mass on input. We're going to take a radius here on input, and now we just need to assign our formula. So if you remember, now I usually over bracket things until I'm familiar with what the calculator actually does, but we want GM over R or minus GM over R really. So there's my minus. Let's put on my alpha lock again, and we've got G, and we want that to be times M. So we got our minus g times, we want m. So we got our minus g times, we want m, so alpha lock m, and we want to make sure that that gets divided by our value that we stored in R. So your GM over R is your potential. I've got brackets here, so I'm okay, divided by R. And what happens now is if I just click, we'll keep it very simple, click EXE and then exit. Then this program, if I exit again, now here we go, pot 1, let's actually run this program. So enter a mass, let's put in the mass of the Earth, 5.98, sorry, 5.98 times 10 to the 24. Yes, I am reading it off my data sheet, like you know and love your data sheet. So that's our mass, and if we put the radius of the Earth, which is 6.37, let's get this right, 6.37 times 10 to the 6, and you're betting yourselves now, what would we expect the value of the potential to be at the Earth's surface? If you remember from some of the work we've done in class, it was about minus 63 megajoules per kilogram. So there you go, now you've got a program and it can calculate potential for any mass and any radius. Our assumption is that the mass is a spherical mass, a point source even really, but at least this will work for you, and there's all sorts we can do and make other programs. This was my first program and I'm glad I've shared it with you, and I hope you have a go too. Thank you.